so let's get started. My presentation's on large-scale anthropogenic impacts to natural resources and ecosystems, and overview. What I mean by overview is that this is basically going to be a list, and it's going to be an incomplete list because there are so many impactors to our environment currently, so many impactors that are connected as far as matter and energy flows in systems on a systems-wide scale, systems within systems. It's very complex. But there are some overarching impactors that should be addressed and probably should have been addressed on a civilization-wide scale years ago. But here we go. Oh, hold on. Okay. Yes. So human beings, as you know from environmental science, are ecosystems engineers. Make a little window here. Okay. Part of the reason we are able to thrive as a civilization, and one of the reasons that we evolved the way we did, and we overcame a lot of adversity early on in our evolutionary arc, was because we were able to manipulate tools and manipulate energy, especially mechanical energy and combustible heat energy at first. At the beginning of the dawn of mankind or humankind or whatever, people somewhere along the way, millions of years ago, discovered how to make fire, how to set fire to things, and utilize that for cooking food, for heat, and all that. And of course, we've been using tools since we evolved. Higher order primates use tools too. We're a higher order primate. Other ecosystems engineers, oddly enough, do not include chimpanzees, but they include beavers, the mangrove crab, which actually moves sediments around. It alters the sediment budget of the large, gigantic mangrove ecosystems on the shores of the oceans. Gophers dig extensive tunnels throughout, wherever they live, which is in the midwestern part of the United States, the Great Plains. And fungi, fungus organisms are ecosystems engineers. They live in these giant microbial, mushrooms, fungus pads. Biologists may be able to help me with this. Within the soil, so they occupy soil layers. Okay. Can you guys still hear me? Can you hear me?
Yes, we can hear you. Yes.
Okay. Just I had another call here. So they occupy, whole areas. A mushroom colony can live under whole acres, and they biochemically alter the soil ecosystem. But we have been able to harness energy to alter the entire planet's biosphere, alter its lithosphere, alter its atmosphere, alter its hydrosphere. I mean, this is a graph of just the United States. The consumption of, I think on an annual basis, the United States in BTUs, British thermal units, this is heat, this is energy. And we've done it through mostly, recently, the harnessing of petroleum products. As you see right here, near 1776, we were still wood and, muscle power. And that's the way it was prior to the 18th century for all of human history. Up until sometime around the 1800s, the 19th century, things started to change. We were starting to develop engineer mechanisms that could utilize far greater amounts of energy. And of course, now we've harnessed energy in order to take us to, the moon. Anthropogenic development across multiple scales has altered energy and matter flows on a planet-wide scale, and it's altered biological systems. This is a graph of what they call an overshoot day. Okay, so I think the idea here, it's a little odd. I'm not sure I buy this that much, but I'm sure there's a quantitative measure somewhere that's better than this, but it kind of gives you an idea. The overshoot days so we are overshooting our ecological footprint, which is the impact that we have on the planet locally and then planet-wide. The advance in days means the advance that we get towards, I think, some very unsustainable future. Again, all this indicates that we're overshooting our ecological footprint, and we are. We've been overshooting our carbon footprint. It has to be said that the impact that we've had on this planet has afforded us like a historic, unprecedented quality of life, high standard of living. We have, the use of technology and science has impacted the planet in a lot of very negative ways, but it's impacted the planet in a lot of positive ways too. And it's impacted human civilization in a positive way. We have advanced medicine. This COVID pandemic that we're in, they will find some sort of vaccine or treatment for it. We have survived the Spanish flu. We have better technology than during the Spanish flu. There are problems on a political, social, and economic level, of course. But as far as technology goes, no. Okay? But the scale and rapidity of our development have come with costs. It's global warming. They say, okay, it doesn't exist. Look in the past, the Earth is warmed. Well, has it warmed as quickly? No. It's the rapidity. It's the scale and the rapidity, the speed at which things happen, events unfold. Get my little window, my little finger here. Okay, there we go. So I'm just going to list out some of the impacts on our planet. Okay, anthropogenic means human cause. Okay, well, one of the anthropogenic impacts is just the fact that there are a lot of us, and we are multiplying in the number of people. We're exponentially, at a great rate, increasing the number of people on the planet. Let me get rid of that. I'm sorry, Haley Berry. I'm glad she's shaving her head. You go. Okay, anyway. So this is a problem. Granted, there is a lot of open space out there across the Earth's geography. A lot of it is not capable of sustaining a human population, though. There are vast tracts of Siberia, even the American West, which are underpopulated. But again, those are very difficult places to live. We tend to occupy the easier places to live, the seashores, the rivers, the areas at the equator, places that are comfortable for people to exist in. Okay, so that's a problem because these places get vastly overpopulated. We're seeing the advent of megalopoli. I'm not sure which one to say, but these are cities that are on a colossal scale, like the connection, and pretty much the connection between Washington, D.C. and at least New York City is almost intact. It's almost a megalopolis right now. So this has an impact on the planet because there's a lot of us and we're doing a lot of things. We do a lot more things with energy and matter than other organisms. So one of the other impacts is agriculture and irrigation. Okay, there's another area where maybe the biologist might be able to help me out with. Okay, so through agriculture, often to produce high yields and enormous amounts of food, and to control, control is one thing we use our energy for, we do monocultures. Monocultures are problematic. One of the main reasons they're problematic is because if you get a disease in a crop, the entire crop becomes diseased, generally, because there's no resistance. So The Irish potato famine of the 19th century was caused because of a potato blight in the main type, and pretty much the only type of potato they had in Ireland at the time, which fed pretty much everybody. They were called lumper potatoes. And when they were basically clones of each other. They were, I suppose they were like hybrids of each other. This is more in the realm of the biologist, but they were all basically the same, much like bananas today. And when one potato got sick with the blight, they all did, and they all disappeared, and there was a famine in the human population. So if you have more diversity in your speciation, in your genetics, you're going to be able to resist these diseases. And this probably holds true of us human beings right now. And there are other factors, of course. Irrigation has had a tremendous impact on the planet. We irrigate whole swaths of the world in order to produce food. Well, one of the problems with irrigation is waterlogging. A lot of plants, if you just spray an entire field, you waterlog, an entire field, a lot of plants will drown. A lot of plants can't exist in saturated conditions. Also, in arid areas, once the water evaporates, you have salt development because you have the ions of salts present in the water and in the soil and the rocks and minerals of these areas. And salt development occurs once the water evaporates. That's a problem, too. The Aral Sea was an arid area, and you've had saline buildup in the Aral Sea over time. The Aral Sea is in Central Asia, and the Soviet Union utilized the Aral Sea for irrigation of huge amounts of wheat over many years. And because the Aral Sea is in somewhat of a losing state as far as its groundwater, if you've been in my class, the gaining water table connects to the water surface of a surface stream or lake. But when you have the water table deep down, you have a losing situation where there's leakage of water. So as they were extracting water to grow wheat and other crops in the Soviet Union and Russia, they were depleting the Aral Sea. And now it's just a fragment of what this inland sea used to be. And this is through irrigation. Another anthropogenic impact is mining. Okay, with mining, you have the production of minerals because you're moving minerals around in solution. Just mining itself deep underground, you're going to hit a water table at some point. You're going to release sulfur. You're going to produce protonation. Protonation is going to occur, and that, of course, leads to acid mine drainage. Okay, there are a lot of other impacts with mining. There's mountaintop removal, which is the absolute devastation of a mountain ecosystem because you're literally blowing up the top of a mountain to get usually coal. But, of course, coal has its problems because it's incredibly non-sustainable. You've got the pollution. You've got the carbon dioxide production for greenhouse gases, and you've got, devastated human communities, too, as well. So this place that I have pictures of here is Summitville in Colorado, and I've been there as part of a geology excursion. It used to be a gold mine. It was a low-yield gold mine, meaning they had to chemically separate the gold from the rest of the ore, okay, using chemicals, in this case cyanide. And so the gold was separated, and then you have spoil, which has to be sequestered. Well, in this case, the spoil, water leaked into the spoil and ended up as runoff water, and it ended up in the valleys. There's strong indication of the contamination in the water supply. This mining also released copper, and the copper complexed with arsenic, which is often present in orogenies or mountains. Okay, the Brahmaputra and the Brahmaputra River, which runs from the Himalayas to the Bangladesh, has a problem with arsenic. It's shed off of the mountains. It's just naturally produced. And of course, arsenic is very poisonous. Well, what happened with Summitville is the production of energite, which is a mineral. It's a copper arsenic sulfate, and okay, right there, and it has a salt bonding. So right there, you have something that if it gets in water, it's going to separate out. You're going to separate out the arsenic. You're going to end up with arsenic buildup in your valleys. So this mine was shut down years ago, and the owner skipped with like $300 million, and the EPA actually had people up there with guns to protect it because there's still gold there, apparently. It was a pretty massive disaster for this area of Colorado, which is in the Sangre de Cristo Mountains of Colorado. So mining has massive impact, plus mining is unsustainable. Once you mine something, the only thing you can do with the metals is repurpose them by recycling. Once you get it out of the ground, it's gone. It only develops over geologic time, which is enormous, and long periods of time. And there's air pollution. Well, one of the, I guess, a good positive feedback mechanism of this COVID pandemic has been that a lot of factories have been shut down. A lot of people are driving a lot less, so nitrous oxide is not as heavily produced, especially from automobile exhaust. And that map on the left right here is tropospheric nitrous oxide, which is, of course, the troposphere. The troposphere is the layer that we live in, the layer of the atmosphere we live in. So, this is a good thing. It came from a bad thing, but this is a comparison between the same days in 2019 and 2020. And this is thought to be directly attributable to this pandemic because people are driving less and production's down. Hopefully, when we bounce back, maybe we can kind of put a break on some of our driving, some of our production. We can kind of try to do a handshake with the environment. I don't know. Well, we'll see. On the right is a graph indicating National Institutes of Health, indicating the cases of asthma in infants who were born around 1952, 1953 during the Great Smog of London, when because of atmospheric conditions and the amount of coal production that was occurring in steel production, you had a massive cloud of smog that descended on London and killed thousands of people, or at least 1,000. But a lot of infants developed asthma at around that time, and it's thought to be, of course, that this smog was attributable to that. So the gases we put up in the atmosphere also include a suite of greenhouse gases, carbon dioxide, methane, nitrous oxide, and others. So again, the Earth has warmed up before. There have been no polar ice caps before in Earth's history. In times like the Carboniferous and portions of the Mesozoic era. But there's a rapidity to this increase in CO2 that is not in the historical record. It only occurs now. And these graphs, the one on the top left, is the history of carbon dioxide accumulate concentration taken at the Mauna Loa Observatory that NOAA runs, the National Oceanographic and Atmospheric Administration, in Hawaii. And it's just a steady increase. It's not quite super exponential. It's a bit linear, but it's very steady. And you got close to 100 parts per million over a period of close to 45 years. The one below it is the recent indication. Now, the up and down cycles are seasonal. Carbon dioxide is sequestered in the environment seasonally too. But the trend is steadily upwards. This one on the top right is the mole fraction in parts per billion of methane in the atmosphere. Methane, CH4, is a greenhouse gas. Now, parts per billion, you might think, hey, that's no big deal, right? The problem is methane is, let me look at the notes here, is 28 to 36 times more effective at warming, returning radiation back to the Earth, from the atmosphere than carbon dioxide. Carbon dioxide has a global potential of 1. Methane has a potential between 28 and 36, depending on the time period that you measure and all that. Now, the one below it is of great concern because that's sulfur hexafluoride, okay, which is used in industrial applications, medical applications. It's used in industry as a dielectric, which is kind of an insulator kind of material. It's also used as a tracer for environmental studies. So and it's utilized in, of course, again, like in the medical field. So it has its uses, but it volatilizes, and it has a global potential of 23,900. That's 23,900 times more effective at re-emitting back to the surface of the Earth heat or radiation than carbon dioxide. And it is increasing, as you see. This is from sometime between 1995 and 2000. And again, parts per trillion here, but because of its effectiveness and because it is increasing steadily, it's kind of a concern. Water pollution, okay, as you've taken my classes, I discuss constantly how all water on Earth is interconnected. And this is a route for transport. Water has an overall negative charge. It tends to attract the cations of salts, and it also attracts organic material very well. It moves it around. So if nasty organic pollution gets in your well, it may actually be connected to a surface body of water and get in a river. And then that's something that the water filtration plants clean up. We have a great system of water filtration plants in this country and in a lot of parts of the world. Even toxic pollutants are often sequestered. I mean, not always very effectively, but we really try. The Clean Water Act has done a great job of helping to clean up our nation's waters from filthy polluted back in the 50s and 60s to very nice now. Now, of course, Flint, Michigan, there are outliers. There are places where, we're just not doing our work, okay? But in general, we have pretty clean water. Of course, the Clean Water Act, as well as the Clean Air Act, is kind of being pulled back now because our government has gutted a lot of agencies that deal with environmental remediation. That's kind of a bad thing. But let's move on to the ocean's acidification. Okay, acidification of the oceans. The oceans have a mean pH. At least they started out at a mean pH of something like 8.14 or 13 or something like that. You see the little the light blue surrounding that line. That's an overall trend in lowering ocean pH. But as you see with the darker blue, that's an increasing concentration of the partial pressure of carbon dioxide. There's just more carbon dioxide in there. And it, of course, is, has a linear response to the amount of atmospheric carbon dioxide. So why is the ocean acidifying a concern? Well, it's because a lot of ocean organisms thrive in high pH or basic conditions, and as they get acidified, they are going to lose their ability to make their shells and to even survive. A higher than 7 pH, a pH of around 8, a little more than 8, is crucial to the health of our world's oceans. If they drop down below 7, and that could happen in thousands of years, or if you get very significant in hundreds of years or even 800 years, you'll see a lot of species die off, and you'll see the ocean's health compromised. It'll be a different ocean. Okay. All right, what about construction and solid waste? Well, construction industry, when, developers are building, especially in places like here in North Georgia, where you have a lot of rain, you have a lot, it's a pretty humid environment, you have a lot of water running off, you have a lot of water erosion. Well, development, because, you clear-cut fields, you strip these fields of all the roots, all the plants, everything to hold the soil down, you end up with a lot of erosion. And that absolutely batters the land surface. You end up with these washes. I mean, you've seen them probably of Georgia red clay and just rust staining highways. And you see a lot of mass wasting and bank slump in rivers and creeks. There's sediment development. There's siltation of Lake Lanier. Lake Lanier itself is a giant construction effort. All lakes north of the fall line, north of that line between Augusta, Macon, and Columbus in Georgia, are artificial. They were built. They were dammed. They're engineering projects. All of them built pretty much by the Army Corps of Engineers, including Lake Lanier. I've been to Lake. I was at Lake Lanier yesterday. It's kind of almost settled in as a natural, feature, but it looks natural, but it's not. And you end up with siltation in certain parts of Lake Lanier, and that siltation can lead to the buildup of algae and lead to eutrophication, which is low oxygen, high nutrient. Eutrophication leads to low DO or no DO, which is a fish kill situation. You end up eliminating aquatic life. The bottom middle graph right there is just a giant canal engineering project. Just moving vast areas of the earth around has impact. Okay? It leads to just increased erosion all around. And this erosion is matter, is sediment that is carried by waterways like rivers into ultimately the Earth's oceans. Along with this sediment comes our trash, our literal, like plastic trash, which has a very long degradation time. Now, engineers are now creating, and scientists are creating plastics that have a high biodegradability, which is good. That's what we need. But the plastics that are already there have very slow biodegradability. In fact, some of them don't even degrade at all, really, over many, many years. And this stuff ends up in the ocean. And because the ocean has a lot of complex circulation going on in it, there are areas of stillness that are kind of like giant whirlpools called gyres. And within these gyres, once plastics and other materials are captured, they get sent to the center by the sort of vortex effect. And you've got this thing called the Eastern Garbage Patch, the Great Pacific Eastern Garbage. Okay, thank you, Adobe. Great Eastern Garbage Patch of the Pacific Ocean. And it's within an area known as the North Pacific Subtropical High, which is a climate system of high pressure, which tends to be very calm. So around it you have circulating waters in a cyclical fashion, and everything's kind of sucked into it. You have this giant, you can visit it. It's just a giant patch of garbage. And there's a bunch in the ocean now because of our solid waste. We've been pretty good about solid waste, but we have so much waste, so many waste products. You buy a CD or a DVD, you have all this packaging, that covers up the product. And with the packaging, you just throw it away. A lot of that stuff ends up on the ground. A lot of that stuff ends up in the waterways. Then you just go to the creek, the stream behind Perimeter, Clarkston campus. There's shopping carts in there. There's bags in there. And we have poverty in this country in a lot of places on earth. There's a huge amount of poverty in the United States. It's somewhat shameful when we think of ourselves as a developed nation. It doesn't seem to be that way. because of the amount of poverty. And with poverty comes desperation and waste. And so you end up with garbage in the middle of the ocean. And the one you probably knew I would get to. Again, this is more of the realm of the biologists. But I do understand deforestation. So our encroachment on wilderness areas and wildlife, the habitats of animals and other organisms have had great impact. Biodiversity has steadily been declining. We are seeing increased rates of species extinction. The extinction rates are going up and up and up. And a lot of human beings on the planet are utilizing wild animals for various reasons, folk medicine, even food. Now, it's understandable from an economic standpoint. Some of these people on Earth are impoverished. And when you're impoverished, you do what you need to do. So you can't really even blame the people. You've got to blame the situation. But our encroachment on the habitats of wildlife, leading to habitat fragmentation, led to extinction, and it's led, apparently, according to a lot of medical and biological scientists and ecologists, this is what ultimately led to the zoonotic development, which means the zoonotic means a pathogen in toxicological terms that vectors from animals to humans. And these pathogens, especially COVID-19, or it's actually the real name for it is SARS-CoV-2, I think. The disease is COVID-19 that we get. But the COVID virus that we're dealing with now jumped from pangolins to bats, I believe. And in parts of the world, there is a trade in wild animals. The pangolin is apparently, I just looked it up today, the most traded wildlife species on Earth. It's kind of cute, little pangolin. It's got scales. People use it for all sorts of things, but it is a wild animal. And of course, with bats, I read about this today too. In China, apparently they've had whole-scale extermination of bats, I guess, to just get rid of them as a nuisance. And of course, these pathogens that the animals can sort of deal with get to us, and we can't deal with them. I mean, other animal to human transfers of pathogens has happened in the past. Another thing I read about, again, I'm not a biologist, but I read about this, and then apparently it's true. Leprosy used to be a problem on this planet. Well, the only other animal that I've read about that can, yes, mosquitoes too, the diseases that we get here, and of course ticks, Lyme disease is a problem of a lot of people. I know people who have Lyme disease. But the only other animal that can transfer or contract or have, I guess, or at least give it to people, leprosy is the armadillo, which of course we see around here all the time. There's armadillos everywhere. So this is an impact of great consequence to us right now, because we are in a pandemic and our lives have changed. And a lot of it comes to our encroachment on wildlands and, unfortunately, the mismanagement of wildlife and wildlands. And again, people who are in poverty, there's an exploitative situation there, and they tend, folks that, you got to do what you got to do to survive. You might need to eat something that, most people don't normally eat. And these are very complex problems, and they go beyond just the pandemic. They go into, of course, the economic problems, and we're starting to see that too right now. Perhaps these potential impacts should have been addressed long ago. A lot of the research that has gone into understanding our anthropogenic impacts are decades old. Scientists have known about this for a while. Whether science is implemented as policy, that's another story, unfortunately. Okay, well, these are the acknowledgments. I looked up a lot of stuff, a lot of reputable organizations. One that's semi-reputable. Does anybody have any questions or concerns? And again, thank you for your patience. It was very frustrating to me. I got all punk rocked out about this stuff, and but I'm glad that we're here. I'm glad you're here, and to my students, I'm glad that you're going to do some extra credit. I really appreciate your efforts during this really, really trying time.
Well, thanks for persisting, Steve. This was really an awesome talk, and I think we really all needed to hear about it. So let's give Steve a hand of applause. And if you have a question, you can
please do. If you have any questions, let me know.
Yeah, you can type it into the chat box or unmute yourself.
Yeah, typing's fine. And thank you. Thank you, Trung. I really appreciate it. And again, this was a list. You could write volumes about this. I mean, there are volumes. When you go to the Wikipedia page on anthropogenic impacts, you have a massive page, a list, and it's linked to a bunch of other pages and with a bunch of other cited sources. The research is enormous. I mean, this stuff is reading. What's that?
Oh, there are a couple of questions. So here's one. See, what happens to landfills when they're overfilled? Do we pave over them?
Yeah, that's a good question. Often landfills are turned into parks. A well-managed landfill will utilize biological organisms, bacteria, which breaks down a lot of the materials. You can actually turn a landfill into a park. Now, they're not always well-managed. And when that happens, you end up with pollution. You end up with contaminants leaking into the aquifer systems connected to the surface water, and you end up with, water that needs to be cleaned up. That's one of the biggest problems with landfill. They have to be well-lined or leakage occurs, and when that leakage occurs, it gets in the waterways. That's a good question.
There's
see the one about the... What's
sorry.
that?
There's a related question. I mean, I'm skipping over one question here, but we can get back to that. There's a related question to landfill. So the landfill in South DeKalb, Georgia, has become bigger than Stone Mountain in recent years. I wonder what we will do with this.
That's a good question. Hopefully, DeKalb County will address leakage somehow, and hopefully sort of move the stuff around to where bacteria can be introduced. And you see, decay is actually a good thing. Once decay occurs on garbage, then you have a pathway to having that garbage remediated. Me, you start my video, and I'll say hi. Okay. So hopefully that's dealt with. Now, if the landfill in South DeKalb County has become bigger, and if there's cracks in the leaks in the liner, usually you have to line a landfill with both plastic and clay. You have to prevent that leachate material, which is water containing organic chemicals and contaminants. You have to prevent it from going to the water table and into waterways. If that is happening, then we need to step up efforts to clean up the water, and hopefully that's occurring. This is the first time I've heard about it, and I'm actually going to look into this because this is something I could use in my classroom. So thank you. Let me scroll up a little bit. I want to thank you.
There was another question about the oceans,
wait.
garbage patches.
You said that. Wait a second. Yeah, I'm kind of... Okay, Latoya, thank you so much. That was a good question. I appreciate that. Let's talk about the ocean. I've got a lot of questions here. Is there anything... Okay, from Shannon, Siobhan, thank you. That's a good... Siobhan, that's a good question. Is there anything being done to help with the trash piles in the ocean? Yes, there is. There are a lot of people out there who are doing regular beach cleanup. I mean, it may seem silly. It's just you walking along the beach, la-di-da, maybe with your dog, and you're cleaning up garbage. But that works. And more people that do that, the more that we put our hands into cleaning things up, regardless of what's going on, even on a governmental level. Sorry to say. I mean, it breaks down, and it's been breaking down. The more we put our hands into doing this, the better things will be. We have to do this, it seems, and we can. It's just very simple. Pick up the garbage around your neighborhood. Don't throw things out the window. People do that still. Just throw their garbage out the window. So when it's loose, the air and the water will carry it. And the air and the water will carry it into the water. And the water will carry it eventually into the ocean. And we end up with the situation. So on a large-scale level, there are organizations working to clean up the oceans. It would be nice if more of the Earth's governments did that too. And maybe we'll see that. I don't know. I can't really address political issues.
Yeah, that's what the next question's about.
Yeah, scientists aren't the greatest communicators, and we're lucky if we have politicians and officials and policy individuals who are there who will actually talk to us. Those are the individuals we need. Let's see. Mount Trashmore, yeah, I've heard of that. Robert, not scientists' job to communicate. Mass media has failed us because freedom of the press belongs to those who, well, yeah, I hear what you're saying, Robert. I hear what you're saying. Daniel, why don't the state government of the ocean do anything to get the trash out of the United States Ocean? That's a good question. Let me see. Okay, hold on, just scrolling. Also, is the government planning, come on, control, hold on. Got a little clicker. Come on, clicker. There you go. Is the government planning to find alternative ways to eliminate trash or reduce the amount of trash in the waste? I don't know. I don't know whether the government's doing it. Some companies are acting on their own to be more quote-unquote green, reduce packaging, and all that. And that helps, corporations and companies that make the effort and implement systems to help eliminate waste, they're great. And this is what we need more of. Governments planning to eliminate trash in the oceans, I don't know. I actually haven't heard of any governmental policy that enacts to clean up the oceans. It's all been on a local level.